There's a lot of properties about parallelograms that you can figure out on your own if you just play around with them for a little bit. In order to be able to show you what I'm talking about, we're going to explore parallelograms here on software that I have. Just try to figure out what's going on and what's true about parallelograms and what isn't. This is going to make understanding how to do these problems so much easier. I'm going to build a parallelogram here, and I'm going to run through the steps very quickly. We have a parallelogram, and I'm going to drag a point and move it around a bit. It's just changing into different shaped parallelograms, but all the sides are still parallel. All right, now let's do some exploration. So you might have a question about the different sides. How are the sides related? So let's do some measuring. AB is 18 centimeters. Let's check that one with DC. Oh my gosh, look, they are the same. We'll check the other sides, and they are the same. So one of the properties is that opposite sides of parallelograms are congruent. Let's check some angles. So angle A is 128 degrees, but angle B is 52 degrees. They're not opposite angles. Let's just check the other ones and see what's going on here. There's probably a pattern. Ooh, angle C is 128 degrees too, and angle D is also 52. Let's get rid of all these labels because it's easier to look at this without all the letters. So we know that opposite angles are going to be the same size, but is there something going on with these angles that are not the same, like the 128 and the 52? Well, let's check that. Well, look at that. So if the angles are consecutive next to each other, then they're going to add up to 180. So consecutive angles are supplementary. Let me put the diagonals in here and let's explore those a little bit. I don't think these are the same size at all. One is way longer than the other one. Oh, but look at this. One is twice as long as the other one. I wonder if that's true all the time. Nope. But it looks like that point in the middle is cutting them in half. Well, that's weird. Let's change my precision on my measurement here. Okay, that works better. So here's what we figured out. Diagonals cut each other in half. The better way of saying that is that diagonals bisect each other. So those are the main properties of parallelograms. If you want to see how to use those properties to solve some problems, click into this video next.